Okay, everyone, we're going to start chapter 2, which is trig functions of acute angles. And you might remember from a previous discussion about what acute angles are. Acute angles just means that your angles have to be between 0 and 90 degrees. So we're looking at basically anything in quadrant 1. No, my Q didn't draw out. There it goes. Quadrant 1. Anything in quadrant 1 from our ASTC chart. And so instead of defining our trig functions as an x and a y and an r, we could base it strictly on a triangle using the sides of a triangle. So a right triangle based definition for a trig function is that for any acute angle, they use a here instead of theta, but any acute angle that you have in standard position, then you can do sine, cosine, tangent, and their reciprocals based on the sides that are either opposite, adjacent, or the hypotenuse. So this goes back to the triangle that I drew in the last section that I said you have to just kind of squint a little bit to notice it's the right triangle. So like for instance, if we have angle A, angle B, angle C, and you're going off of, say, angle A here, like what we're doing here in the definitions, then this side over here becomes your opposite side. This is your adjacent side because that side touches the angle, and the hypotenuse is always going to be your diagonal. And there's a few different ways that people remember this, and it's usually based on the sine, the cosine, and the tangent. One such way is SOHCAHTOA. SOHCAHTOA. This tells you that sine is the opposite over the hypotenuse. That would be this definition here. Cosine is the adjacent over the hypotenuse. That would be this definition here. And tangent is the opposite over the adjacent, which would be this definition here. And there's lots of different ways that you could, remember other than SOHCAHTOA. One more popular one is that some old hippie caught another hippie tripping on acid. So that's another way you could do it. This only tells you the sine, cosine, and tangent. You still have to know that the other three are reciprocals. So, some helpful angles from triangles. Man, I can't spell because I left the L out of triangles. So if you print it off your notes that are blank and you want to fix it, maybe I got it right on those notes. I'm not really sure, but there's an L right there between the G and the E. Triangles, helpful angles from triangles. There's a 30, 60, 90 triangle, and there's a 45, 45, 90 triangle. And I have those two triangles drawn down at the bottom of the screen. 30, 45, and 60 are 2 or 3 angles that pop up a lot throughout trig, and I mean a lot. If it's not those angles, it's usually some multiple of those angles. And so those come up so much that they're usually either needing to be memorized or memorize the triangle at the very least. So from your 30-degree angle, the 30 degree, this row right here is going to come off of this angle. And since sine is the opposite over the hypotenuse, the 1, this is your opposite side. This becomes your adjacent side, and this is your hypotenuse. So sine is the opposite over the hypotenuse. That's 1/2. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So that would be 1 over root 3, or if you rationalized it, root 3 over 3, by pulling the radical up and then dropping the radical sign off on the bottom. I'm going to go ahead and do the 60 degrees since that's the same triangle. 60 degrees would go off of this angle. On that angle, this side is the opposite, this side is the adjacent, and the hypotenuse is the same no matter what. So sine would be the opposite of the hypotenuse, which would be root, oops, I put that in the wrong spot, didn't I? Would be the root 3 over 2. Cosine would be the adjacent of the hypotenuse, which would be 1/2. Notice these are just backwards from the 30 degrees. That's not coincidental either. And tangent's the opposite of the adjacent, which is root 3 over 1, which is just square root of 3. And for the 45-degree angle, it doesn't matter which one you use. I'm going to use the lower right, but you could use the other one if you wanted to. It doesn't matter here because the opposite and the adjacent are going to be the same number, and the hypotenuse is the root 2. So the 45, opposite for sine, opposite over the hypotenuse, will give you root 2 over 2 if you rationalize it. Cosine will give you the same thing because they are the same sides. You might also remember that since the sides are the same, two sides are the same, that is an isosceles triangle. And then the tangent would be the opposite over the adjacent, which is just 1. So these values pop up a lot, well, no matter how far you're going in the math, whether it's just to finish trig, or if you're going to go into Cal 1, Cal 2, Cal 3, Cal 4, these particular values pop up a lot. So if it says to give the exact value of tangent 60 or secant 45, I would go off of those triangles. Tangent 60 we just did, but just to do it again, 60 degrees would be right here. And I would have 1, 2, root 3. This would be the opposite side. This would be the adjacent side. The 2 is the hypotenuse, but we don't need that for tangent anyway, because tangent is the opposite over the adjacent, which is root 3 over 1, or square root of 3. So if it's either a 30 or a 60 degree angle, then this is the triangle I would use. If it's 45 degrees, like the second one, I have to do the 45, 45, 90 triangle, where you have 45, 45, and you have 1, 1, and root 2. So going off of this 45 in the corner, this would be the opposite side, this would be the adjacent side, this would be the hypotenuse. Secant is what you get when you flip over cosine. So what I would do is take the cosine of that triangle and then flip it over before I wrote it down. Cosine is the adjacent over the hypotenuse, so we're actually doing the hypotenuse over the adjacent. So the hypotenuse is root 2. The adjacent is 1, so I just get square root of 2 for my answer for the secant of 45 degrees. So, a few examples. We'll do a couple of examples like this. Here's a triangle where all the sides are listed, and we're going to find the sine of angle A, cosine A, tangent A, and so on off of that triangle. So here, angle A is actually the angle up on the top. And so across from it, this would be the opposite side. The 10 would actually be the adjacent side, and the 26 would be the hypotenuse. Remember, the adjacent side is the non-diagonal side that touches the angle. The opposite side does not touch the angle that you're working with. So sine is the opposite over the hypotenuse, which is 24 over 26. That's a 6 there. You might also notice all of these have a multiple of 2 on them, and you could divide it off of the triangle, or you could wait and divide it along the way, but this becomes 12 over 13. This is a 5, 12, 13 triangle, if you know what that is. Cosine is the adjacent over the hypotenuse, so that would be 10 over 26, or 5/13. You may also notice the sine and the cosine always have the same denominator. That is not a coincidence either. And tangent is the opposite over the adjacent. So that would give me 24 over 10, or 12/5. Another thing you may also notice, which is not a coincidence either, is that the tangent is always the numerators of sine divided by cosine. So the 12 from the sine divided by the 5 of the cosine, that's also tangent. And that's not a coincidence either. Then the other three are just flipping them over. Cosecant would be 13 over 12, then 13 over 5 for secant, and 5 over 12 for cotangent. And we could do this with numbers, or we could do it with letters. And now, when we're doing it with letters, though, we're going to switch the angle. We're going to go off angle B now. So angle B makes this side be opposite, this side be adjacent, and remember the hypotenuse is always the diagonal. So sine of B would be the opposite over the hypotenuse, that is m divided by p. Or the cosine would be the adjacent over the hypotenuse, n divided by p. Or tangent would be the opposite over the adjacent, which would be m divided by n. Again, the numerators from sine and cosine, not coincidental. And then cosecant, secant, and cotangent, you just flip each one of those over. So I'll get p over m, p over n, and n over m. And that's how you would do it if you just had letters or numbers. Okay, this one says find the unknown side using the Pythagorean theorem, and then find the 6 trig function values for the angle B. So I do highly suggest that you draw the picture out here to make sure you get everything labeled correctly. So if I draw my picture, that's probably the best triangle I've done so far. I'm going to say angle A is here, angle B is up here, angle C is here. Remember, sides are always across from the angles. So when it says I have a side A equals 6, side A is always across from angle A, side B is always across from angle B, side C would be across from angle C. To find side C, I did the Pythagorean theorem. So I'm going to do the A squared plus B squared equals C squared and solve for C. So I'll get 6 squared plus 8 squared equals C squared. That is, 6 squared is 36, 8 squared is 64. That makes 100. So C was 10 if you take the square root of that. This is also a 3, 4, 5 triangle. It's just been doubled to make it 6, 8, 10. Going off of our angle B here makes this side be the opposite, this side be the adjacent. That's supposed to be a J, by the way. And of course, the diagonal is always the hypotenuse. Sine is the opposite over the hypotenuse, so that would be 4 over 5 if we simplify it. Cosine is the adjacent over the hypotenuse, or 3 over 5 if we simplify the 6/10. And tangent would be the opposite over the adjacent, which is 4/3 if we simplify it. And then we just flip each one of those over. Cosecant is what you get when you flip over sine, so that's 5 over 4. Secant flips over cosine, so that's 5/3, and then we'll have 3/4 for cotangent flipping over tangent. And those would be your 6 trig values. Not too bad, hopefully. Then we have what are called cofunctions, and people mess up the idea of a cofunction with a reciprocal. Cofunctions come from the idea of the complements. So complements are two angles that add up to 90. We talked about that in the very first section. And so a function of a certain angle would be the same thing as the cofunction of the angle that makes those two angles add up to 90. And I think cofunctions are the easiest ones to figure out because the co gives it away. So if you have sine and you want to know its cofunction, you put the word co in front of it and you get cosine. That's why sine and cosines are cofunctions. Or if you have secant and you put co in front of it, you get cosecant. That's why it's the cofunction. And same thing with tangent. If you had tangent and you put co in front of it, you get cotangent. So if you had an angle, sine of any angle would be the same thing as cosine of 90 minus that angle. That's why if you notice back on some of the other ones, on one of the charts that we did, things like sine of 30 degrees and cosine of 60 degrees, they're the same thing because these are cofunctions of each other and these two angles add up to give you 90. That's why they come out to be the same thing. And you can do that identity for all of them. Cosine is sine of 90 minus the angle, or secant is cosecant of 90 minus the angle, and you can do it for all 6 of them. And so that is what a cofunction is. And then it pops up a lot for the 30, 45, 60, 90 angles, all of those acute angles that we're talking about in this section. So if it says to write each function in terms of its cofunction, if I have secant of 39 degrees, that would be the same thing as cosecant of 90 minus 39. Or if you just subtract it, 90 minus 39 is 51 degrees. And that would be the same number if you typed it in the calculator. Secant 39 and cosecant 51 would be the same number. So if I did secant of an angle plus 15 degrees, I do the same process. I would say that this is cosecant of 90 minus theta plus 15. But you end up distributing the negative across. So it'll be a minus theta minus 15. So I get cosecant of 75 minus theta. And this would be the same value as secant of theta plus 15. Or if we went the other way around, instead of being a plus an angle, we could do minus an angle like on part C, where it says cotangent of an angle minus 10 degrees. Cotangent and tangent are cofunctions, and they're the only ones that are really kind of confusing because tangent and cotangent are reciprocals and cofunctions, so a little bit of a hiccup there. But this becomes tangent of 90 minus theta minus 10. And again, the negative just distributes across to make this 90 minus theta plus 10. So this is tangent of 100 minus theta. Or you could do it with decimals. And I'm guessing I meant to have that spaced over so they'd line up more, but oops. So sine of 38.7 degrees. Sine would go to cosine, so this would be cosine of 90 minus 38.7. And it's okay if you get a decimal, that's fine. So 90 minus 38.7 is going to give you 51.3. And that's how you would write the cofunction of each one. Now this says find a solution for the following. This is very much like one of the problems that we would finish the last stuff with when we did reciprocals. Here, these are going to end up being cofunctions of each other. So sine and cosine, since they're cofunctions of each other, that means the two angles have to add up to be 90. So I take the 2 theta plus 10, and I add it to the 3 theta minus 20 and set it equal to 90 if they are cofunctions of each other. That gives me 5 theta minus 10 is 90. Add the 10 to both sides, and you get 5 theta equals 100. Divide by 5 on both sides, so theta is 100 divided by 5, which is 20 degrees. And that would be my answer for the first one. And I do the same thing on the second one. Now notice tangent and cotangent, like I said a while ago, is both cofunctions and reciprocals. You can't do the problem both ways. So there's no way to rewrite tangent in terms of cotangent where they're equal like this. If they had a 1 in there, then you could adjust it. So the ones that we did before, we had tangent equaled 1 over cotangent. That 1 in there makes it be the reciprocal. There's no 1 here, so we can't do that. So they are treated as cofunctions in this case. And I say that 3b plus 4 plus 5b minus 10 equals 90. So the 5b and the 3b make 8b. The 4 minus 10 makes negative 6. So I can add the 6 to both sides and get 8b equals 96. So b is 96 divided by 8, which is 12 degrees. And that would be my answer for those variables. And so then we could apply what all of that is with the acute angles, and we could apply it to non-acute angles. So non-acute just means you're not looking at the angles between 0 and 90. That could be any other angle of any type anywhere in the world. So it could be anything between 90 to 360, but it could also be, negative numbers or things bigger than 360. All of that would be true. So to do that, we have to come up with something called a reference angle. So a reference angle is the positive acute angle made by the terminal side of an angle and the x-axis. So trig functions have the same values as they have in the angles for quadrant 1, but the only thing that will change is either it'll be a positive value or a negative value depending on what quadrant you're in. And so we use the reference angles to make sure we're in the right quadrants. So reference angles are always between 0 and 90, and this book labels them with an apostrophe or a prime after the theta. So we usually call that theta prime. And to find the reference angles, then in quadrant 1, the reference angle is its own angle. You don't have to do anything. But in quadrant 2, you do 180 minus the angle. Quadrant 3, you do the angle minus 180. And in quadrant 4, you do 360 minus the angle. Notice all of these angles, all these definitions, all of these things down here are based off the x-axis. So when you're doing your formulas, you have 0 degrees, you have 90, you have 180, you have 270, you have 360. So the only angles you're using for the reference angles are the ones on the x-axis, either the 180 or the 360. You don't ever add or subtract 90 or 270. And so just for an instance, if I was to draw an angle out, say I put an angle over here in quadrant 2, for instance. So here's my angle. If this would be my angle theta, my reference angle is this part right here. Ever how much it takes to get back to the x-axis as quickly as possible. And so in quadrant 2, you subtract 180 from the angle and you'll get that little angle on the inside. That's the reference angle. So it says find the reference angle. First of all, you have to figure out what quadrant you're in so that you can apply the right rule. And some of the angles might be too big or too small, so we might have to adjust them. So the 134 degrees, going off our little chart here, you have 0, 90, 180, 270, and 360. 134 is between 90 and 180. 134 would probably be somewhere about right here. And so that's in quadrant 2. So in quadrant 2, the reference angle is 180 minus the angle. So our angle is 134. So I just have to do 180 minus 134 to get a reference angle of 48 degrees. Now the 315, or the negative 315, that is not good. We need numbers between 0 and 360. So before I started here, I would add 360 to it to get it to be something between 0 and 360. So I can use that ASTC chart kind of thing. So if you add the 360 to it, I would get 45 degrees. 45 degrees, that's in quadrant 1. That's between 0 and 90. It's 45 degrees. This is in quadrant 1. And so in quadrant 1, theta prime and theta are the same thing. So the reference angle is 45 degrees. That one's fairly simple. Don't even have to subtract anything. The 670, though, is too big. So we're going to have to subtract 360 to make it be something between 0 and 360. So that'll give you 310 degrees. 310 degrees is between 270 and 360. This is actually quadrant 4, between 270 and 360. In that instance, my theta prime is 360 minus the angle. So I would do 360 minus 310 to get a reference angle of 50 degrees. And notice your reference angles are all acute angles between 0 and 90. They're supposed to be. You cannot have a negative reference angle, for instance. And so all of these angles are your reference angles. So when it asks you to find the exact value of 6 trig functions given a certain angle, well, what we could do is you could use those 30, 60, 90, and 45, 45, 90 triangles to come up with the values, but you have to use the reference angle on that triangle. So the 225, this is an angle in quadrant 3. It is between 180 and 270. So in quadrant 3, my reference angle is the angle minus 180. So I would do the 225 minus 180. That will give me a reference angle of 45 degrees. I then go to the triangle. Since it's a 45 degree angle, I look at my 45, 45, 90 triangle, which looked a lot like this, if you might remember. I want the 6 trig functions for 225 degrees. What I want to do is take the 6 trig functions based on 45 degrees, the reference angle, and then adjust the signs. So I would do sine of 45, which would be 1 over root 2, or root 2 over 2. Remember, we're doing, in this case, off of that angle, the opposite, the adjacent, and the hypotenuse. And sine is the opposite over the hypotenuse. Cosine would be the adjacent over the hypotenuse, which is actually the same thing. Notice they're cofunctions, and 45 plus 45 make 90, and so that's why they come out to be the same thing. And tangent 45 is the opposite over adjacent, which is just 1. Now, when I do these, I only do the first 3, sine, cosine, tangent, because I'm going to adjust them to the 225 anyway, and then I'm going to flip them over. So there's no real point in doing secant, cosecant, and cotangent on the reference angle part. You can if you want to. I just don't. Now, since we're in quadrant 3, this goes back to your ASTC chart. In quadrant 3, notice tangent is the one that's positive, which means everything else, the sine and the cosine, have to be negative. So when I write my answers, I'll say that sine of 225 is the same thing as sine of 45, but since it's in quadrant 3, it has to be negative, so it's negative root 2 over 2. And cosine of 225 would be the same thing. They're both negative in quadrant 3. But tangent being positive, I actually get the same positive one that I got when it was just 45. And then I take each one of those and flip it. So cosecant of 225 is what I get when I flip over the sine part. The 1 over root 2 would make just root 2 if you flip over. So that's just square root of 2. Secant 225 would be the exact same thing, because you're flipping the exact same value. And cotangent of 225, if you flip over the 1, you get 1. And there is all 6 trig function values for 225 degrees, based on the 45s. Let's do another one. 690. Not only do we have to do that same process, but 690 is too big. And so we'll have to subtract off 360 and see what happens. So if you subtract 390, that's not 390, sorry. If you subtract 360 before we do anything else, you'll get an angle of 330 degrees. That 330 degrees, that is in quadrant 4. So in quadrant 4, I have to do that my reference angle is 360 minus my angle. So I'm going to do 360 minus 330. That'll give me 30 degrees. And that is an angle that I can use my 30, 60, 90 triangle on. So my 30, 60, 90 triangle looked a little bit like this. Oops. So it had a 1, a 2, and a square root of 3 on the side. And I could pull those values off for 30 degrees, 30 degrees being the top angle up there. So if you're going off of the 30 degrees, oops, force I have it. The 1 is the opposite side. The root 3 is the adjacent side. And the 2 on the hypotenuse is always the diagonal. And then I'm going to write down sine, cosine, and tangent from those values. So sine of 30 is the opposite over the hypotenuse, so that's 1/2. Cosine of 30 is the adjacent over the hypotenuse, so that's your root 3 over 2. And tangent 30 is the opposite over the adjacent, or I could write that as root 3 over 3, whichever one you want to do. Then, looking at my ASTC chart, I'm in quadrant 4. Quadrant 4 says cosine is the one that should be positive. And so I'm going to write down my answers based on all the ones being negative except for cosine and its reciprocal secant. So, and notice, I don't go sine of 330. I have to go all the way back to the original sine of 690 degrees. Would be the same thing as sine of 30, but with a negative in front. So I get negative 1/2. Cosine is actually the same thing. It would be the root 3 over 2. No negative. because of the quadrant. And tangent 690 has a negative in it. It'd be negative root 3 over 3. And then I flip each one of those over to get the other 3. So cosecant of 690 would be negative 2. Secant of 690 would be 2 over root 3, or if you want to rationalize it, 2 root 3 over 3. Pull the radical up and drop the radical sign off on the bottom. And the cotangent would be what you flip over from tangent. If you notice, though, it was originally 1 over root 3, so if you flip that over, you just get square root of 3. And there are all 6 trig functions of 690 degrees. Hopefully this isn't too bad. It's a little bit tedious, but it's not terribly bad knowledge-wise. Just a little bit of work. Okay, this says determine if these are true or false. And again, you could probably do this in a calculator if you wanted to. Sine of 30 plus sine of 60 equals sine 30 plus 60. If you were to do sine of 30 off of the triangle, or off the chart that we wrote down earlier, sine of 30 degrees, this is 1/2. And sine of 60 is root 3 over 2. They want to know, does that equal, this is actually sine of 90. Sine of 90 degrees, you could type that in the calculator, that's 1. So sine of 30 plus sine of 60 is not going to give you 1. This is false. And usually the more complicated it looks, the more likely it is to be true. So this next one, sine of 30 plus sine plus 60, this first part again is sine of 90, which is 1. Sine of 30 is 1/2. Cosine 60, if you went back to the triangle or the chart, would also give you 1/2. Sine of 60 is root 3 over 2, as is cosine 30. So this is saying, is 1/4 plus 3 over 4, is that equal to 1? That is true. So this is definitely more complicated looking than the first part, part A, but it is actually true. And again, you could type it in the calculator to make sure it is true or false. And part C, this one will also be false. Cosine of 60 is 1/2 if you pull that off the chart or the triangle. Cosine of 30 is root 3 over 2. So they wanted to know, is really 1/2 equal to square root of 3, because the 2's would cancel. And that would be no, that is false. And we'll talk about why those are false once we get into chapter 5 with a few different identities and things. Okay, it's usually harder for most people to go the other way around. Instead of giving an angle and then spitting an answer out, what if I gave you an answer and you tell me what the question was? This is very much like Jeopardy. So find all the angles between 0 and 360 that would make sine theta equal 1/2. So it's a little bit harder. You're trying to come up, there's usually multiple answers for theta to make that true. Because remember, if you're looking for where sine theta is 1/2, if you looked at the ASTC chart, sine is positive both in quadrant 1 and in quadrant 2. So there's probably an angle both in quadrant 1 and in quadrant 2 that would make it true. Now since it's in quadrant 1, that's nice because those will come directly off the triangles. So the 1/2, that was one of the ones that we just looked at off of the 30, 60, 90 triangle. So off this 30, 60, 90 triangle, this 30 degrees would have an opposite side of 1 and then a hypotenuse of 2. Or you can look it up off the chart. So one of the angles would be 30 degrees. Sine of 30 is 1/2. But since it's also in quadrant 2, we have to take our formula that our reference angle equals 180 minus the angle. That's the quadrant 2 reference angle. Here, my angle that I'm working with, the 30, is actually my reference angle. And so since I'm in quadrant 1, my reference angle and my other angle, my original angle are the same thing. So 30 is one of my answers. The other answer would be put 30 in here and solve it for theta. If you move the theta over and subtract the 30 over, then I'd get that theta is 150. So my answers are 30 and 150. And you can check those too. Type them in the calculator. If you did sine of 30, you should get 0.5, and if you did sine of 150, you should also get 0.5. On part B though, tangent theta is negative root 3. To be negative root 3 with tangent, the negative tells you can't be in quadrant 1 or 3. That's where they're positive. So on this one, we're looking at these two quadrants, 2 and 4. But the root 3 still comes from the same triangle, the 30, 60, 90 triangle. Since tangent is the opposite over the adjacent off of a 30, 60, 90 triangle to get square root of 3 is 60 degrees. So my reference angle is 60 degrees. And the reference angles are coming off of the triangle or off of the chart that we wrote down a few slides back. And you can look, tangent 60 degrees would be root 3 over 1, which would be root 3. But we are looking in quadrants 2 and 4. In quadrant 2, that's the same formula we just did. Our reference angle is 180 minus our angle. In quadrant 4, our reference angle is 360 minus our angle. So we put the 60 in there on both of them. And you solve it for theta. And I'll let you all do most of the rearranging and such, but you'll end up with theta being 180 minus 60. So theta ends up being 120. So there's one of the angles. On the other one, you'll get that theta is 360 minus 60. So theta is 300. That's the other angle. And like I said, most of the time you're going to get two answers. And then cosecant being -2, what I would do, I'd never think of it in terms of secant, cosecant, cotangent to do this process. So I would do the reciprocal. And so I would change it to not be cosecant, but the reciprocal of cosecant is sine. So I would change this to be sine theta is -1/2. Now we already did sine as 1/2. That had a reference angle of 30. So C has the same reference angle. Reference angle is still 30. But we're in two different quadrants. Now we're in the bottom two, quadrant 3 and 4. So for quadrant 3, that formula is that your reference angle is the angle minus 180, and in quadrant 4, same as before, it's 360 minus the angle. So if I plug that 30 in there, I'll get 210 degrees equals theta for the first one. And the other one, if you plug the 30 in there, again, I'll let you all do most of the rearranging, you'll get that theta is 330 degrees. And that's your other angle. And that's how you would do acute and non-acute angles from 2,1 and 2,2. Most of this will get absorbed into, if you ever seen Trig before, there's a big chart called the unit circle. We're working towards that idea, and all of this will get absorbed into that chart. So you have really two ways to do Trig. Do all the triangle stuff that we're doing now, or you can do the unit circle when we get to that point. And that's coming up in about another 3 sections or so, maybe 4 sections. So hopefully this makes kind of some sense. And again, if not, let me know.